Hi there, guys. Well, we are about to start chapter 3 in the Oxford IB HLAA book. And this is mostly about complex numbers. And let's just take a moment to appreciate that it's pretty exciting to go beyond real numbers and then start talking about these imaginary numbers. So to extend the number system doesn't happen often that we do that. It's pretty exciting that we're going to do this. Right, but before we get there, we've got exercises 3A to 3E to do, which are essentially a consolidation of the things which you should have done before, which is work on quadratics, for example, completing the square, quadratic inequalities, the quadratic formula, the discriminant. So there's quite a lot of work which we're building on from before we move on to complex numbers. One of the things which this is talking about in the micro concepts here, it says, in this chapter, I was just reading from the left, in this chapter, you will also learn about one of the most important theorems in mathematics, the fundamental theorem of algebra. And that tells us that if we have a polynomial of degree n or of order n, so for example, a quadratic has degree 2, then you should get 2 roots for that formula, for that equation or for that polynomial. So, for example, a quadratic normally gives us 2 roots, right? 2 solutions. You normally get 2 places where the quadratic crosses the x-axis. If we're going to plot it as y is equal to this function, then set it equal to 0. So a solution to the polynomial of order 2 would often give us 2 solutions, but sometimes it gives us no solutions, and sometimes it gives us 1 solution. There we go, that would be 1 solution, a repeated root. Now, in this case here, we still have 2 solutions. It's just that 2 of them are complex. Okay, so there are always 2 solutions, whether they're complex or whether they're real. Okay, so that's what that's telling us. Anyway, that's going to turn up later on. And let's just do a little bit with complex numbers as well, just as kind of a taster. Things like, I don't know, 3 plus I would be a complex number. And this would be your real part, and this would be your imaginary part. Now, what does this I mean? Well, the I, some people will already know, I means the square root of -1. Okay, so the whole foundation, the basis of complex numbers is to use these i's. Okay, so this is equal to I. We don't have to put a line under anything. It's not a vector. This is just what we call I. Okay, now we know that this can't exist. We can't do the square root of a minus number. At least it can't exist in real terms. But essentially, we take the maths forward by saying, well, let's assume that it does exist, and then what happens when we take that forward? Okay, so this would be an example of a complex number with 2 parts, this imaginary part and this complex part. And if I doubled that, I could say I've got 6 plus 2i. Okay, and I could get rid of that. I could put this on an Argand diagram as well. So an Argand diagram tells us that we've got a real axis and an imaginary axis, and this point would plot as this number would plot as a point on our Argand diagram of 3 across and I up. So this would be the scale of -I there. Of course, you've got -3 on that side to come up with symmetry. And so there we go. That would be our point on the Argand diagram, which represents this number. Okay, so that's just a little sort of teaser for complex numbers. In fact, we need to now go on and do some work on, before you know stuff, but then do some work on quadratics. So I'm not going to spend much time talking about the ideas. I'm just going to go straight into the question here. So I know a lot of people would have done work on quadratics before. Now it starts off super simple. It says, solve the following quadratic equations by factorization. Well, in this case, you should know, of course, that you're getting 2 numbers which times together to give you the -40 at the end, and they should add together to give you the +3. And that's the little puzzle which we're solving. So add together to give you the +3 there. Okay, and if we can solve that little puzzle, then we can find out how this factorizes, and we can see in this case that the numbers timesing together to minus 40. Perhaps we've got 10 and 4, so we have to consider our factors here. Now, we definitely know that when we add them together, we should get a positive number. So it's going to have to be the larger number, which is positive in this case. We can see that that one doesn't work because that gives us plus 6 when we add those two numbers together. So that's not working. So we've got to think of other combinations here and combinations which are closer. So maybe 8 and 5 is a combination which is closer. And there we go, we can see that plus 8 and minus 5 both times us together to give us minus 40, but adds together to give plus 3. Okay, super boring for most of you, okay? So let's just make that really quick. All right, so there's our factorization. You should all be able to do that. Okay, for the next one, again, most of you can do this and have a technique for this too. And again, it relies on us saying two numbers timesing together equals to minus 4, and the two numbers adding together to, sorry, not minus 4, equal to, sorry, AC in our quadratic. In our quadratic, we're defining as AX squared BX plus BX plus C is equal to 0. Okay, so what we're saying here is that this needs to equal to AC. The addition of these two here needs to be equal to the B still. Okay, that's the puzzle which we need to solve. Now 2 times minus 4 gives us minus 8, and when we add the two things together, equal to 7. Now, although 2 times minus 4 is equal to minus 8, that's not necessarily the combination that works here. Okay, so let's consider combinations here. Well, we had the 2 times the minus 4. See that when you add them together, you're going to get minus 2, so that's not good enough. And well, I can see that the numbers need to be further apart. So perhaps 8 and 1, seeing as we have a negative number when we add them together, that means the larger of these two needs to be negative. So the larger magnitude needs to be negative, so it's going to be minus 8 there. Okay, once you've got that sorted, then you replace your middle term with, okay, so you can replace your middle term with minus 8x and plus x. You've got the minus 4 on the end, and that's equal to 0 still. Okay, that's just by working out on the side. And so what we've done is we've replaced this, look, this has become minus 8x and plus x. Okay, we've essentially done that by using these two numbers here. Okay, so what do you do after that? Well, you need to factorize this. So that's 2 and x as well. So we factorize the first two terms, x and minus 4. We're expecting x minus 4 to turn up in the second bracket as well. And in fact, it's actually just x minus 4 there. So in a way, it's plus 1 lot of x minus 4. And then when you factorize that fully, you can say, well, we've got 2x lots of this and 1 lot of this. Gives us a total of 2x and 1 lots of x minus 4. So that's the technique that most people know. And then, of course, you can go ahead and solve these by factorizing, by then saying, okay, well, either this has to be equal to 0, so we go 2x plus 1 is equal to 0, or this equals to 0. So we've got two options. So from the second option, we're getting x is 4, and from the first option, we're getting x is equal to minus a half when we solve that equation. So those are your two solutions that we're getting which solve this equation here. Okay, now for this technique here, this technique which I've gone through, this is not exclusively the only technique. There are other techniques for this. And I'm not just talking about what some people say is just going commando, which is just it's just trying to think about your combinations. And I have to say, in exam situations, they normally give you numbers which are easy enough to figure out. So in fact, here you don't have too many combinations to go through before you can figure it out just by going through combinations. So for example, what I mean there is you can put 2x and x here. That's definitely going to be the case, assuming that it does factorize. And then we've got to think about our combinations on the other side. So we could have here 1, 4, 4, 1, 2, 2. And then, of course, you could have this being minus and this being positive, or each of those being the other way round as well. So you could have minus 2, and then you could have that whole thing the other way round as well. Okay, so there is going to be a combination out of these which works. So we've got the 1 and the minus 4, and the 4 and the minus 1, and the 2 and the minus 2. So one of those 6 combinations works. And you can go through in your mind, go through those combinations and just think what's going to work here. So, I mean, let's just see again. I think it was, let's just try one of these. Okay, so we can see if we start with this, we're going to get 4 times 2x, it's going to give 8x, and then minus 1 times by x. So when you combine those two middle terms, that's going to give you plus 7x. In other words, 8x and then minus 1x. So I can already see that that combination is quite good, but it's got the sign the wrong way around. But then I would go to this one here. So you can also get lucky straight away, and I've kind of got lucky there as well. Okay, so yeah, so that would be minus 4, that would be plus 1, so you can check that. So, but there are other methods even other than that one, but I'm just not going to go there at the moment. Okay, so if you have a look at the way the book does this, I thought was kind of a little bit annoying. I mean, the book is good in general, right? But it says here, again, split the middle term and factorize in pairs was the only explanation that gave this to this. And you're thinking, well, how do I split the middle term? And that's the big question. How do you split that middle term? And there was a whole lot of working out that went in before you can split the middle term. And so, in a sense, the book is really, although it's providing a solution there, it's really assuming that you know how to do this already. Okay, let's have a look a little further on. Oh, that gives you 3a. Brilliant. 3a is done. Okay, and now we're going to go on to completing the square. I'm going to fit this one in as well, and then I will stop on this video. So there's an investigation, nice little investigation which you can do, but I'm not going to do it through that. It's just example 2 and 3. Okay, so let's take the example 2 here, and it says for each quadratic expression, so not an equation in this case, it says find the value of k which makes the expression a perfect square. Hence, write each in a factorized form. Okay, so what do they mean by perfect square? Well, they mean, for example, if we take x squared plus 2, then we got x squared plus 4x plus 4. So this is a perfect square for this thing here. Okay. So the perfect square is just a set of brackets with a square on the outside. It's something squared. That's what they're talking about. Okay, so these questions are really not that tricky, and just trying to get you to think about that. It's just saying, well, we've got the a text there. Well, in a perfect square, remember when I times out, let's put x squared plus 2ax plus a squared. Okay, so this perfect square form gives you this when you multiply it out at the bottom. So you can see that the 8 is going to be equal to your 2a, so it's going to be equivalent to that in the multiplied out perfect square form. So when we put it back into the completed square form, or the perfect square form rather, then the a is going to be 4, because 2a is 8. Okay, so we take that back. Okay, so this is actually going to be plus 4, and when we multiply that out, we're getting x squared plus 8x, and then plus 16. So k for the first one is plus 16. So have we answered the question now? It says find the value of k. Yes, we found the value of k, which makes the expression a perfect square. Yes, we've done that. And then hence write each of the factorized in a factorized form. So that's the factorized form for the first one. Okay, and in a similar way for the next one, again, remember we have this is our model which we're trying to make, okay, plus a squared. I mean, you know there, of course, that when you multiply that out, you're going to get a plus x twice, a times x twice, which gives you the 2a x in the middle there. Okay, so again, if we compare this to this, we can see that the minus 7 is equal to 2a. So a is equal to minus 3.5, or minus 7 over 2. And then a squared is going to give us the 49 over 4. So 49 over 4 has to be equal to our k in this case here. Okay, you will notice that it's always k plus k. You're always getting a plus something at the end. It doesn't matter if you put in a plus or a minus here. It doesn't matter what you're putting in at the end. Whenever you square it out, that last term always becomes plus a positive number. Okay, so k is equal to 49 over 4. And then to put it in its completed square form, you're just going to say that's in its perfect square form. You're just going to say, well, that's half 7 and then squared. Okay, k is equal to 49 over 4. Right, for the last one, have a little look at the last one. Now, by the way, you might have a different memory of completing the square than this, but it's just trying to get you to think about the structure of it to start off with. And then there is kind of a formula which you can use for completing the square as well, which we'll come on to in a bit. Okay, so for part C, you can see here that you've got the 9 in front. So really you need to take out the 9 to start off with. Hang on. How would I do this? There's probably 2 different ways of doing this one. So if you can see ax plus b. Now I'm doing it the way which I think is a kind of problem-solving route, because I can see that this one's got 9x squared in front. So if I multiply this out, I've now got a squared x squared plus 2 lots of abx plus b squared. And again, I can equate this to equal to this, and then I can put it in this form here, or at least I should be able to. Okay, so 9 we can see is a squared, so a is going to be equal to 3. And then because 2ab is equal to 3 here, so I've got 2ab equaling to 3. And because I know that a is equal to 3, the 3 and the 3 is going to cancel, and I'll end up getting b is equal to a half. So that's pretty straightforward. So now that b is a half, we can see that b squared is a quarter. Okay, so we can then put everything in. A is going to be quarter, by putting b into that, and this all came from this form here. And then we can then write this as a perfect square, and we can say, well, we've got 3x plus a half squared, and that's our perfect square there. Okay, so just checking with the book, we can see that they've done pretty much the same thing. They talk about using the binomial expansion, but what they're talking about there is just using the form of a plus b in brackets all squared. So it's simply the multiplying out of 2 sets of brackets there. Okay, so let's move on to example 3, and it says now solve the following equations by completing the square. Okay, so solve the following equations by completing the square, giving your answers in exact, I should say, form. Okay, so where are we going to start with this one? So similarly, this first one, inside the brackets, we're going to need to put half of the coefficient of x. So if we put half of the coefficient of x here, we put the plus there, because there was a plus in front of that coefficient of x, and we put squared, well, I know that this generates, if we multiply this out, I know it generates x squared, and 2 lots of 5 over 2 times x, which brings us to 5x. But I also know that it generates an extra 5 over 2 all squared. Now, I don't see that in the start of this expression here. I don't see this extra thing here. So if I replace this with this, it's going to give me my x squared and my 5x. It's also going to generate this extra b times b, if you like. But because that's extra and I don't want it, and because it adds it on, when I multiply this out, it adds it on. If I replace this with this, I need to get rid of the extra thing which it's replaced, which is put in. So in other words, see if I can just take this back. In other words, it's true to say that x squared plus 5x is this thing here with the 5 over 2 taken away, with this taken away. That's 5 over 2 squared, that is. So let's do that then, so that we've got x squared plus, sorry, not x squared, we've got x plus 5 over 2 squared, take away the extra thing which it generates, which we don't want, and then we've still got the minus 24. Now, crucially, completing the square only happens with the first two terms here. The extra term at the end is not interesting to us, or at least not at the moment. So this is the completing the square technique. We have now used that technique. Now, the rest of this is just algebraic. Now, the point of doing this is to have a reason for getting x on its own. So, or it's a way of us getting x on its own. So, you know, when you start to try and solve these equations, quadratic equations for the first time, you say, well, look, I'm going to take my 24 to the other side, and I'll take my 5x to the other side, and then I'll try and square root it. And then I realize that I've got 5x involved in my answer, which is not good. So the only way in which we can use lines of algebra and not use a factorization is if we can get x on its own. And we can only do that by using this technique of completing the square. X in two positions is now in just one position. Okay, so if we now simplify this and take that to the other side, so we've got now 25 quarters, and then 24 is the same as 96 over 4. So we can combine those two things there. Okay, it's still not looking particularly nice. 25 over 4 and 96 over 4. That's giving us a total of that minus 121 over 4. So if I take it to the other side, it's equaling to 121 over 4. And now we can square root this. And of course, square root of 121, I'm doing this now. I'm sorry, I'm not putting in all the steps because I'm running out of space. So we're going to get 11 over 2, put a plus minus in there. We don't need that plus there anymore. Plus minus this, and that's equal to this. Now, obviously, show all of your steps, but this simplified to this with a minus in front of it. Take it to the other side, and we get 121 over 4. Undo the square root. Remember to use plus or minus in an equation situation when we're taking the square root. And there is our answer to that. And now the only thing to do at the end is then to say, okay, let's take away the 5 over 2. So we've got our solutions of 11 over 2 minus 5 over 2 is one of our answers. And the other answer is minus 11 over 2 minus 5 over 2. Because, of course, we've got plus or minus. So we have to consider both of those options. And that's going to give us our two solutions here. So 11 over 2 take away 5 over 2 leaves us with 6 over 2, which is 3. That's one of our solutions. And for the other solution, we'll get 16 over 2 to minus 16 over 2, which gives us x is equal to minus 8. So presumably this original equation actually factorized. So it's kind of annoying that they told us to do this, but it factorized to give us x and minus 3 and x plus 8. So that was the factorization from this one here. So if we have a little look at how the book is doing this one, it's slightly different. I've just copied this onto here, and you can see that they've built you up through the first example to talk about adding something on to make a perfect square. And I've done it a slightly different way around. So they've said, well, onto these two terms here, we're going to need to add on another term in order to make that perfect square. And if we do that to one side, we're going to need to do the same to the other side. Now that's different to the way in which I explained it, because I said, well, let's take half of the coefficient of x, put that inside the bracket, and I said, well, that generates the first two terms, but because it generates an extra 5/2 all squared, we need to take that off because we don't want that. That's not here. So I've dealt with it like that instead by replacing these two terms with this here. And then I've taken it forward from there. So there's a slight difference in the way in which the book has done it. Okay, so part B is the last thing I'm going to do in this video. And for part B here, we've got 2x squared minus 7x plus 1 is 0. Now, the plus 1 you can kind of ignore for the time being. The completed square form technique only works with the first two terms. So if I take a 2 out to start off with, because I don't know how to complete the square easily with the 2 in front, so I'm going to take the 2 out as a factor here. That leaves me with 7 over 2x there as well. So I haven't taken out the x, just a factor of 2. And I've not completed the square there just yet. I've not done that technique. I've just taken the 2 out, and now I'm going to complete the square with this bit here. Still the plus 1 on the end, still equals to 0. And now this, to my next line, is going to be the completing the square trick. So we're going to take half of the coefficient of x, so we need to half that again. Takes us down to minus 7 over 4. We're going to square that, and then we're going to take away the extra thing, which is this is generating, which we don't want. So this generates x squared, this generates 2 lots of 7 over 4 as the coefficient of x, the minus there. But we also end up getting 7 over 4 squared out of this thing here. So because we don't want that, because it's not in the row above, we need to take that away. So there we go. That's the same thing as the thing which we have in yellow in the previous line. So now I need my brackets around this, just as I have my brackets around this here. Still got my 2 there, I've still got my 1 there, and that's equal to 0. And the bit in yellow is completing the square technique. Okay, well, I just messed up my next bit of working out because I didn't give myself enough space to do my lines of working. So there's a lesson. Just give yourself another enough space in order to do your lines of working. So now where can we go from here? Well, we can actually simplify this. We've got 49 over 16 there, and we've got 2 there. This time I'm going to use working it out. So we've got that. And you've got options now. You could take the 1 to the other side and divide by 2, or you could multiply the whole of this by 2. Well, if we multiply the whole of this by 2, we'll get 2 lots of the first thing, and then the 2 is going to cancel with the 16 there. This is essentially 2 over 1, and so that's going to give us 49 over 8. And I've got the plus 1 at the end there as well, but I will put the 1 as an 8 divided by 8. Okay, next little bit is we can combine these, and we could take them to the other side. And here again, I'm tempted to cheat and do all my steps at once. If I put these two things together, I've got minus 41 over 8. So 41 over 8 on the other side. And then we've still got 2x minus 7 quarters divided by 2. Now we're going to divide by 2, so that's now 41 over 16. And I'm going to cheat again because I'm running out of space. So then we're going to do the square root. And so square root, remember in an equation situation, we need to have the plus or minus there. So x minus 7 over 4. So our final answer is going to be equal to plus or minus this, but I can see I can split that up. So I've got plus or minus, I'll put that on the top, divided by 4. So that still gives me my plus or my minus. I've just put that on the top instead. But you can see as well that the divided by 4 spans both of these things on there. And this fraction as well has a divide by 4. So we can put the 7 on here too. Again, I've kind of missed out a couple of steps, but at least I've got it right this time. Okay, so now that's the same as using the quadratic formula, and some of you will know the quadratic formula as well. In fact, most people will. And next time round, we'll prove maybe the reduced version of the quadratic formula, where we don't have an a here. But there's a lot of steps to prove the quadratic formula from the completing the square technique. And essentially, it's taking this forward by using completing the square, but it's just quite a lot of steps, so I'll probably do a reduced version of it next time. Anyway, this gives you the quadratic formula, in other words, solutions of minus b plus or minus b squared minus 4ac divided by 2a after many lines of working out. Okay. Right, well, good. That's done. Quite a long video in the end. Let's just see what's coming up next then. So we've got 3b, not many questions there. And it's quadratic formula next time round. Okay, guys, well, thanks for listening and see you next time.